All right, so let's look at this problem. So here we have, this is an example of how to find or how to create a confidence interval estimate for the sample mean. Okay, and this is the situation where sigma is unknown. Remember, so that means this is the situation that we most often use because we most often don't use sigma. And I'm going to just put in here, remember our formula. The big thing here to remember is when sigma is unknown, you're going to use this as your error formula. Okay? What you see here is a sample from actually 10 different samples of brown rice, and this is the measurement of arsenic in milligrams per serving in that brown rice. We're given the raw data as opposed to the summary statistics. So what I need to do is I need to take this data and actually find its mean. And so if I throw that into the calculator, the mean is 6.35 and the standard deviation is 2.32. All right? So if I'm not given those pieces of information and I'm just given the raw data, it's a simple matter to find them by plugging them into our calculator. So using this sample of size 10, I want to find, we want to create the 90% confidence interval estimate of mu, of the true mean, the population mean of arsenic levels in brown rice. Okay, so here's how it looks. Basically, we take our samples, our confidence interval is going to be this. It's going to be our sample mean plus or minus the error, right? And we have a formula for the error. I've already given that to you up here. So the error we're going to use, this is the error formula. We know what S is. I've calculated it. We know what N is. N is 10. The only thing we don't know is what T is. So this is where we have to use our table. All right? So we're going to take a quick little look at our table. All right? So we open up table A3, and its whole purpose is to give us these critical T values. And so you should be seeing it there. What we're looking for in this table are two things. We need to know the area in one tail. So since we're creating the confidence interval, the 90% confidence interval, let me just draw the picture so you can remember. What that means is this, right? We're looking at a distribution here. We've got two boundaries. And we need, since it's the 90%, that means the middle area is 0.9, and that means in this tail is 0.05 and 0.05. The area in one tail is 0.05. All right? So that means we're looking in our table, and we're going to grab area as 0.05. So we're using that column right there. And then degrees of freedom. Degrees of freedom is our sample size, which is 10 minus 1. So degrees of freedom is 9. So that means we are using 1.833 as our t-score in our formula. All right? So let's write that in. The error then is going to be 1 point, what was it? Let me look it up here. Yeah, 833. 1.833, that's our t-score, times S, which we calculated, 2.32, over square root of 10. And so that comes out to be 1.3. We get to use one more decimal place than the mean and standard deviation that we're the same. We're going to use the same amount of decimal places, so 2. So 1.34. So that's our error. So that means we can find our confidence interval by taking 6.35 plus or minus our error. And so 6.35 minus the error. Oh, let's put in our error there. We've got it, don't we? So 6.35 minus 1.34. So that means 5.01. That's going to be the lower bound. And then to find the upper bound, you're going to add 1.34 to 6.35, 7.69. And this is our 90% confidence interval right there. So we're 90% confident that the mean, the true mean, the true population mean of arsenic levels in brown rice is somewhere between 5 and 7.69, right? And we get that and that level of confidence just from this sample of size 10. So that's how you create a confidence interval for sample means when sigma is unknown.